All right, here we have a problem. We recently polled 700 people, or somebody did, who worked indoors and found that 278 of them smoked. Okay, but now that was an old survey, so we're going to look at a new survey, and if the researcher, or if we want to know, and we want to be 90% confident of the results to within 3.5%, how large a sample is necessary? Um, so we're going to use the old numbers. We're going to use the 700 and the 278 for our p hat. So we'll take 278 and divide that by 700, and we end up with a p hat of 397. So that's p hat. So that means that q hat is going to be 1 minus 3.97. Okay, and so we end up with q hat as 0.603. Okay, now from this, now we want to be 90% confident, so we're going to use 1.65 for that, and then E is our margin of error, or standard error. Anyway, so we're going to use this. Now we have to be careful with this. This is given to us in a percentage. We need it in decimal form to put it in our formula. So we're going to use 0.035. Okay, now from all of this we can get a sample size. Now sample size for proportion is n is equal to p hat times q hat, okay, times, okay, divided by e all squared. Alright, so what we'll end up with is 0.397 times 0.603, okay, 1.65 over 0.03, okay, and square. Now, so we type all that in. Okay, and when we do that, we end up with 533. Well, if you didn't end up with that, if you ended up with something a little bit less than this, remember we're rounding up for this because, again, we can't have a tenth of a person or anything. So our sample size for this one, we should go get 533 people. If we want a margin of error, we want the maximum error to be 3.5%. Okay. All right, now here's another sample size problem. Okay, now a manager of a supermarket wants to estimate the proportion of customers that use food stamp at the store. How large a sample is required to estimate the true proportion to within 3% with a 95% confidence? Alright, first of all, we're not given p hat. Okay, so we're going to estimate p hat to be 0.5. So q hat will be estimated to be 0.5 as well. So we're estimating these values since we don't have any previous knowledge of this. Okay, our E we're going to use is 0.03. Okay, remember we're converting this percentage to decimal. And then for this, we'll use the 1.96. Okay, so we're going to use the same formula we used in the last problem where we had p hat times q hat. Okay. Okay, so we'll plug in here. So we end up with 0.5 times 0.5. Now remember, these numbers are estimates. Anytime you're not given a proportion, we're going to estimate it to be half. Okay, and then okay, and so what we end up with here for sample size is 1067.1, and it repeats. But remember, we always have to round up on sample size, so we need to go get 10,068 people, or that's how many people we need to talk to and see if they use food stamps at the store. Alright, now this one's another sample size problem, but it's a little bit different in the fact that we're not looking for proportion. Now, how do I know that? First of all, we're told standard deviation. So standard deviation is 100. Okay, our 90% confidence level, so we're going to use the 1.65. Now our E here is 15. Be careful here, we're talking about milligrams, we're not in percentages, so it's 15 for E. Okay, so from this information, we can come up with our sample size. So since we have standard deviation, this is the formula we're going to use. Okay, so we just plug all this in, so we end up with 1.65 times 100, all divided by 15. Okay, and so when we plug all this in, we actually end up with a whole number this time. We need 121 nickels in this case. Alright, here we have a study of Peachtree showed that the average, average, remember average and mean, we're talking about X bar, so that's going to give us a hint to which formula we're going to use. Was 1500, so that's the X bar. The standard deviation is 100. Okay, so for sample size, we're going to use the formula that has standard deviation in. So we have a standard deviation of 100. We want to be 90% confident. Okay, and we want our error, if we were down here, to be within 20 trees, or 20 peaches per tree. Okay, so E is equal to 20. Again, it's not a percentage, so we're not moving the decimal or anything here, so E is going to be 20. Okay, so we're going to use the same formula we just used for the last problem, where we have N times Z alpha sub 2 sigma over E, and we're going to square all that to come up with our sample size. Alright, so we end up with 1.65 times 100, all divided by 20. Okay, and we're going to square this, and so we end up with 69. We need to sample 69 trees if we want to be within 20 peaches of the average. Alright, here it says the dealer wants to know the average age of their customers for advertising purposes. They want the margin of error to be 3 years. 3 years. Error to be 3. If you're 90% confident, how many people do you want to survey, assuming a standard deviation of 10? Alright, so standard deviation is the key word there. So we're going to use standard deviation of 10. 90%. Use 1.65. 3 is going to be our error. So E is equal to 3. Okay, so from this information we can come up with how many people we need to survey to see how old they are. What we'll do is we'll take the 1.65 times 10 all divided by 3, and we'll square this. So N is going to be equal to 30.25, but remember we can't have a fourth of a person, so we need to go survey 31 of our customers, or this dealer needs to survey 31 of his customers to figure out their average age if he wants to be within 3 years. Alright, here we wish to estimate 90% confidence the proportion. So that means P hat. Okay, of iPhones that have problems by the time the product is 5 years old. Your estimate will be accurate to this, so that's going to be our E. Now it's in percentage, so we need to convert that to a decimal. So we're going to use 0.025. The true proportion. Find the minimum sample size, assume no prior estimate for proportion. So that if we have no prior estimate, we're going to estimate it to be 0.5. Okay, and so then Q hat will be 0.5. And so we have enough information here to go find a sample size of phones that we need to look at. So 90 again, so 1.65. Okay, so sample size is going to be P hat times Q hat times Z alpha sub 2 all divided by E. And that's squared. So we'll end up with 0.5 times 0.5 times 1.65 over E, which is 0.025, and we're going to square that. Okay, so when we plug all this in, we'll end up with 1089 for our sample size. So for sample size, always remember to round up. Estimate p-hat if not given, if you're looking at proportions, to be careful with that.